Today we turn to a discussion of regression analysis. A linear regression, the topic at hand, is an estimate of coefficients of the linear equation involving one or more independent variables that best predict the value of a dependent variable. A regression analysis, an R-squared coefficient, is therefore a test of internal consistency and allows us to test the strength of any model. In this example, we'll imagine that a graduate faculty has identified the following variables as important to success for students in a master's program in professional and technical communication: writing and editing, document design, rhetoric, problem solving, collaboration and teamwork, interpersonal communication, specialized expertise, and technology. In SPSS, we've entered the total scores for each of those students in the program during this particular point of the study, in this case 67 students, on the variables of writing and editing, document design, rhetoric, problem solving, collaboration, interpersonal communication, specialized expertise, and technology. And we want to investigate the relationship of each of those independent variables to the dependent variable, the overall score. To do so, we'll go into SPSS and go into Analyze, Regression, and select the Linear Regression Analysis. We'll select for our independent variables the model itself: writing and editing, document design, rhetoric, problem solving, collaboration, interpersonal communication, specialized expertise, and technology. For our dependent or outcome variable, we'll select the overall score. In our statistics, we certainly have pre-selected already that we want the estimates and the model fit, but let's also get our descriptive statistics of how these variables fall out as well. We'll hit Continue, and we'll hit OK. Here are our basic descriptive statistics then for each of the variables. In writing and editing, students received a score of 7.07, document design a score of 8.30, and so on down the list. Each of these are the independent variables that are related to the overall score, the dependent or outcome variable. If we go to model summary here, we'll find that our R-square is really quite strong, 0.924. And our degrees of freedom, both regression and residual, are recorded, as well as the F statistic upon which the R-square is related. Our significance here, we find, meets and exceeds easily the 0.05 confidence interval. We therefore are able to find that a regression analysis during this period of portfolios, relating each of the 8 independent variables to the overall portfolio score, revealed a high coefficient of determination. The R-square therefore is 0.924. You'll see the degrees of freedom listed as 8 and 58, our regression and residual, our F statistic listed there, and our confidence interval, indeed meeting and exceeding the 0.05, in this case is 0.01. That is, for this particular run of the model, 92% of the variability of the overall portfolio score represents the proportion of the variation in the dependent variable, the overall portfolio score, that is explained by the independent variables, the 8 core competencies. A regression analysis therefore allows us to test the internal consistency and the strength of our models.